This is section 5.2, part 2. All right, so in this video, we are actually going to look at an example of finding a probability intuitively, so I can show you guys what I mean by that. And then we are going to find some probabilities for a contingency table. And then we're going to look at Rule 3, which is our complement rule. All right, so let's take a look at another example, one that might be a little easier to follow since I'm not just making numbers up, although I did make the cards up. So we saw these. If you watch the Section 5.1 videos, you've already seen these cards. These are my fictional exploding snap cards. And we can find some probabilities using these cards. And so what we're going to do, we're going to find a few just to practice. And just so you can see how I do this with the or and with the intuitive probability. So I'm not pulling out any formulas. I'm just going to look at, mark, and count the number of cards that meet the conditions that I'm setting forth. So first thing I'm going to do is say, what's the probability of getting, I don't know, a star or a gray. And so when I look at that, what I want to do is I might go in and I'll use my little highlighter here. And I might say, well, here's a star. And here's a star. Here's another one. Okay. There we go. So there are all of my stars. And I might go in and say, well, here's a gray card. Here's a gray card. Here's a gray card. And here's a gray card. But I've already marked those last two. So in the end, what I want to do is I want to say, how many cards have I marked? One or the other or both conditions are met. And so when I do that, I say, well, I've got 1, 2, 3, 4, 5, 6, 7. So I don't care that I have 2 cards that are stars and gray. That does not, I want to make sure I count them, but I definitely don't want to count them twice. I don't want to count all the stars and then add all the gray. That'll get me too many. And so instead, I just count them once. And I'm just looking and I see them. I, can point, put my fingers on, mark, somehow, cover up the ones that don't count. And I see that I have 7 out of 12. Okay. All right, so let me, there we go. Let me erase all those marks and then let's look at another one. Okay. So let's say I want to know what is the probability of getting a black or a white. Well, this is a little bit easier. In this case, cards can only have one color. Yes, gray is black and white together, but gray is its own color. So I can mark and I can say, well, 1, 2, 3, 4, 5, 6, 7, 8. And so 8 out of 12. Easy peasy. I don't have to worry about any overlaps because that is what we call disjoint. You cannot have a card that is both a black card and a white card. Let's do one more or. Let's say a black or a heart. And go ahead and if you want to pause and see if you can figure that out and then push play again, that'd be cool because, that's the way it's a little interactive. Or you can just keep listening. So in this case, I'm going to look at the black cards I'll mark them first. There are my black cards, and then I want to mark each of the hearts. And then again, in the end, I just don't want any to overlap. So 1, 2, 3, 4, 5, 6. So half of the cards are either black or a heart. Okay, so you saw an example in your guided notes with a contingency table. And I've got a simpler one here that just has 2 columns and 2 rows. But I do want to show you just kind of as with my explanation of how to use the contingency table and to find probabilities, again, intuitively. So we're just looking at the table. We're not trying to plug things into formulas. And so here is my table. It is pet owners based on whether they are male or female, and then whether they have a dog or cat. And of course we have our total columns too, which is always very handy. Sometimes they don't give us that in the homework, and that's upsetting. I am going to gray this out because sometimes when I am looking at the numbers, I will end up adding all the way across, and I'll end up adding the totals in there with it. So let me see if I can, whoops. Clean that up just a little bit. I'm sure you enjoy watching this part. Okay. I'm not going to worry about losing that. Okay, good enough. So what we're going to do is we're going to look at a few probabilities. So first of all, in a contingency table, whenever I have an or probability, so let's say, if I wanted to just know what's the probability that I select a male, well, the way I read my contingency table is to read across that column, or excuse me, across that row. So male would be a total of 52 out of 100. Similarly, if I wanted to know probability of someone owning a cat, then I would go to the cat column, read down. I have a total of 49 out of 100 cat owners. Okay. And apparently this looks very much like males are more likely to own dogs and females are more likely to own cats. And I don't know. I just kind of found this on Google. So I'll go ahead and be upfront about that. I have no idea where these numbers came from. So somebody could have just made them up. But that's neither here nor there. What we want to do is know, what if I wanted to know the probability of someone being male or owning a cat? Well, I can do one of two things. I can either, and here's where the tricky part gets as far as the highlighting, I can say all the males, which means 52 of them, plus just this additional 39 females, right? I don't want 49 because 10 of those cat owners have already been included, right? We already counted those with the males. Now, if we don't have the totals, this is kind of the neat part, I can just add 1, 2, 3 numbers. And that's going to be my top number out of 100. But I do, so I'm going to say 52 plus 39, which gives me 91. So I'm going to have 91 out of 100. Now, if I said male or dog, changes just a little bit. I still want all of the males, so 52 males, but I no longer want to include those 39 females who had a cat Instead, I want to include the 9 females who have a dog. So it makes it very different, right? Male or cat versus male or dog. Let's look for my pen. There we go. Oops. That would be, let's see, 52 plus 9 should be 61 out of 100. And then, so I could do the same with females. I could say female or cat. So what's the probability that I select a female or a cat owner? Well, let's see. Oh, I was afraid it was going to erase my gray. Okay, well, I'll just take it away altogether. It was a nice try. But now it's just going to be confusing. All right, so female or cat. I'm going to say, well, female. That's 9 and 39. Or cat. That's 10 or 39. So again, I don't want to... oops. There we go. Let me see if I can do this to where it kind of looks straight. There we go. Sometimes it'll let me overlap the blue and the green, and you can tell that it's both blue and green, but it didn't do that this time. But so I can do either one. I could start with 48 or 49. Not really going to be a whole lot of extra work one way or the other. But my first one that I did was female. So if I go along and I say, well, all my females, which is 48, plus I had 10 more cat owners who are male. So that's going to be 58 out of 100. So hopefully that helps with how we use a contingency table to find OR probability. All right, and then we have our third rule of probability. So if you remember, let's go ahead and just review them really quick. So rule 1 was that all probability has to fall somewhere between 0 and 1. So everywhere between impossible and certain, or somewhere in between. Our second rule of probability was that all of our probabilities for every possible outcome, those probabilities have to add up to 1. And I'm just using the symbols. I talked about those two in the previous section's videos. Our third rule of probability is what we call our complement rule. And our complement rule says that the probability that an event, the complement of an event is 1 minus the probability of the event itself. And this is actually really simple if I give you an example and I tell you that there's a 20% chance of rain today. What is the probability that it won't rain? Hopefully you're either saying out loud, that'd be great, it makes me feel better to think that you all are telling me in an out loud voice, 80%. But at least hopefully you're thinking it, right? You're thinking, well then 80% chance it's not going to rain. That's a complement rule. That's all it has. That's all we have to do. We just have to take away, there's a 100% chance of weather. If there's a 20% chance of rain, then there's an 80% chance it does not rain. The thing with the complement rule is that it's basically, either it is or it isn't. And you can do this with a lot of things. So either someone has blue eyes or they don't. Someone has brown hair or they don't. Like I said earlier, if someone doesn't have hair, then they don't have brown hair. So they're in the not brown hair category. If you're trying to list out every possible category, then, what do you do with people who have highlights? Like me, you all can't see because I don't have my video on. But I've got red. I've got some blonde in there. I've got a little bit of brown in there. One of our chemistry professors usually has purple and magenta. So, do you just have a multicolor? Or do you list out all the possible colors? But that part doesn't matter when it comes to the complement rule. Complement rule says brown hair or not brown hair. blue eyes or not blue eyes. So that's what our complement rule is. It's really simple. As long as you just keep it, don't try and overthink it. Now, I will say this. There were some questions that came up where you've got to like complement rule and complement rule again. And that can get interesting, to say the least. Let me see if I can find one of those really quick. Okay, so the example I was looking for is actually in 5.3, so I'll just look at this again when we get to those videos.